Okay, so a lot of time when you hear logic and computer science kind of in the same sentence, people are talking about hardware. They're talking about circuits, they're talking about the thing on which the computer runs, and they use expressions like logic, designs, or Boolean circuit. And you may be wondering by now, all these logics and puzzles and pigeons and treasures, what do they have to do with the hardware? How does all this connect to actually building computers and making them run? So here is a connection. In hardware, people talk about Boolean functions. You make a chip computing a function. And what it means to be Boolean is you only have two kind of values for all of your variables. Doesn't it remind you of something? In logic, we have variables that are true and false. Well, if you call your true a 1 and you call your false a 0, here you got a Boolean function. And you could think of a formula as computing a function for you. It will take as an input a scenario where variables are true or false, call them 0, 1, or true or false, doesn't really matter, just a name. And it will output whatever it evaluates to be. So if a formula is true on a given scenario, you could think of it as a function outputting a 1. And if it's false on a given scenario, you could think of it as a function outputting 0. We call those functions Boolean. Boolean just means that there are just two values, a 0 and a 1. So for example, majority of three elements, x, y, and z, which are all Boolean variables, meaning each one of them is either a 0 or a 1, is a Boolean function. We make majority of x, y, z to be 1 if at least two of those three variables are 1, maybe all three are, and otherwise, if only one variable is 1 and there are zeros, or all of them are zeros, we set majority of x, y, z to be a 0. So it takes three variables, which can be zeros and ones, and it outputs one value, which is 0 and 1. And again, you could think about zeros as falses and ones as true, and it's really kind of interchangeable. So the way to describe a Boolean function is something that you find very familiar. You could describe a Boolean function as a truth table, because how did I tell you what majority is? I said, well, this is that function that will output a 1 when either all three of the variables are true, or the first two are true and the last one is false, or x and z are both true and the y is false, or y and z are both true and x is false, and otherwise it will be false everywhere. It's exactly the same as giving you this truth table, and for each variable you could ask, is this variable a 1? Is it true or false? And you could say whether majority of x, y, z is equal to 1. Is it a true or a false? Well, you know, rather than writing true and false and writing x equals 1 is it true or false, we can write the same thing by just writing zeros for falses and ones for true, and we will also have a truth table. And here it is. The only change that we made is we call the 1 true and call the true a 1 and false a 0. And here is a full description of what majority does on its three inputs. So what's the relation between propositional logic and logic circuit then? How are we getting to the hardware? We started talking about hardware and then suddenly we started talking about functions. Well, logic circuits are essentially a generalization of logic formulas, like the one that you've seen, which compute Boolean functions in the same way that you just seen. For example, if you write the formula x and y, or x and z, or z and y, this formula will be true exactly when majority of its inputs are true and will be false otherwise. So essentially, this is a formula that computes majority. And you could convert a formula into a circuit. Circuits can be more compact than formulas because in circuits you could pre-compute something and then use it in several different places. But generally, the same ideas that apply to formulas apply to circuits. You could talk about truth tables, you could talk about evaluations and satisfying assignments and all of that stuff. We are not going to spend too much time or any more time really in this course on Boolean circuits because you will be in several classes that spend a lot of time talking about Boolean circuits and logic circuits and what kind of things go in hardware. But at least I'm showing this to you so that you would see a connection between that logic design and logic circuits and hardware and the kind of logic that we are studying. It's not by far not the only place where logic comes in computer science. It's just one tiny bit of an application of the logic concepts for one area of computer science. Again, you just saw things like decision trees and automated provers that have not much to do with circuits and with hardware, but have a lot to do with logic.